Okay, so I'm going to share my screen also. I just have today, first, I want to assure you that we are not going to do any PowerPoint presentation. Way back in K University, uh, I've never taught with PowerPoint. But if you join most of our training, you will see most PowerPoint. We are going to do a lot of practicals today. I just want to reintroduce or tell you about those that are making this event fruitful today. Then we can now zoom into our training. So, as Mr. President has said, we are privileged to collaborate with University of Cape Coast, the Representative Council led by the Abraham Normal administration, that's the 62nd UCC administration. And I'm from Elite Research and Data Science Institute. So basically, it's because of them that we are here today. And I'm Ebenezer Senu. I'm the founder of the Elite Research and Data Science Institute. I have a background from a medical laboratory science from Key University, and for the past years after graduation, I've been a research and data scientist, and it has been cool. Today, I'm joining you from North America, specifically in the United States of America, Texas. My research interest has always been molecular and cellular biology. So if I'm in this field, I'm happy to have you. Currently, I'm studying host pathogen interaction of Coxsackie virus. So I'm a virologist, so don't kind of, yes, confuse if we talk more of virus today. And I also want to tell you about Elliot because this is what we do. You can follow us on our social media pages to learn more about us. We have a lot of things going on. We've launched our website, everything. So just Google. Either you go to YouTube, our website, social media, you see us so that you can join our next trainings. Today's roadmap is you cannot deal with research without having Microsoft packages or without having PC. Because first, you start from either your Word or your Excel. That's what we are going to start with. And today I'm going to use SPSS version 26 to demonstrate to you some analysis. I'm also going to use GraphPad Prims to demonstrate to you some analysis. Then we will end with the last 2 hours with George. Is going to also demonstrate to you how to replicate those analysis in R. So sometimes people will say, I want to learn this, but the bottom line is, what do you want to do at this moment? And what is the easiest, most convenient way to do it? That is the key thing. So in case you can do analysis very simple in SPSX and prevent wasting a lot of time, you don't need to go and write a lot of scripts. Or you want to produce high quality graphics for publication, for presentation in top research conference, then you have to produce those graphics in R. We can't go and do that in SPSS. So the kind of circumstance will what requires you to shift to which software you are using. So those requesting to record, I'm sure I've started a recording, so you don't need to request recording. After that, I'll share the recordings with you. So that is the roadmap today. But today is practical, so I'm not going to show anything on PowerPoint, and I'll be moving straight to our research paper. Then we understand some concepts. Then we'll move to the software and also do practice, and we can ask questions. Don't worry about anyway, everything that you have, just ask, and we will be able to do it. As I said, you have to follow us everywhere: LinkedIn, Facebook, X, and you're welcome to join our future trainings. So I'm shifting to this research paper. And I want to confirm again that you can see from my screen. Can you see from my screen? I'm currently on the research paper. Okay, great. Yeah, so today we are using this
Yes, please,
paper.
I can see.
Great, great. So we are going to use this paper as a case in today's training because for previously we joined webinars, we just talk about this without any demonstration. So today's webinar is more special. We are going to look at what this paper talk about. Then part of those data, so the data we are going to analyze is what we use to produce this paper. That tells you that anything we put out there, you have to be able to also reanalyze and produce the same results. Then you're also going to learn some concept of what the paper is about and how did we go about with the analysis. Then you can also apply that in your own project. So this high prevalence of late presentation with advanced HIV disease and its predators among newly diagnosed patients. First, what do you say about this topic? I don't know whether what did you say about this topic? Can anyone give anything about this topic? As I said, just feel free. We are all in this together. Anything, as soon as you read this topic, what comes in mind? You can unmute and talk anything. Anyone? Choices. Do you want to speak?
Yeah,
Okay, let's go. Great.
good morning.
Good morning.
So, a little I can say about this topic is that those who patients who usually come to the hospital, they do not come in the early stages. So, the disease progress from, let's say, an acute stage to a chronic state, or the case worsens before they present
Great.
themselves to the hospital.
Great. So thank you very much. So this is more of, so this more of, it's just telling you straight away that there's high prevalence of late presentation of advanced HIV. So late presentation, as we has talked about, means people are being diagnosed in the late stage of the infection. It can be any infection, not only HIV. For example, currently there's a lot of kidney cases in everywhere. So most people are not diagnosed early. By the time they realize they are being diagnosed in the late stage. But straight away, you will see this paper, there's high prevalence of late presentation. And what I want to tell you is that there's no way someone will start a research, then the topic will be like this. So how did we come about this paper? This is what we call bottom-up approach. It's more of we already know the results, then we bring the topic. But you cannot just start any study, then you say, no, no, no. So this is one way of also kind of deriving topic. So it means that if you're able to do a good statistical analysis, know what you are doing, then you coin a topic that will be more catchy to sell your paper. But anyone that is going to start a research project, undergrad, master's, PhD, will just say that prevalence and factors associated with late presentation with advanced HIV disease. But as soon as you finish your research data, you go to your research process, data analysis, that prevalence and factors associated with, you know it doesn't sell. People will not be citing your work. Then you kind of bring novelty. How do you modify your topic to sell? So as soon as someone read this, automatically it tells you about their story in this paper. telling you that yes, there's this condition, there's high of this condition, telling you that. So that's one way we go to the research. So it means that we have to pass through the research stages, then we're able to arrive at a good statistical analysis. Then from the result, we can generate a selling, compelling what research topic for publication. So that's what we are going to talk about today. So before that, you cannot proceed with statistical analysis without knowing what the research is about. Either you are doing analysis for someone or even your own work. If it's your own work, automatically you know what the research is about. So you know what analysis you are going to do. But if you are research and data scientist or you are just analyzing someone's work, as soon as they send the data to you, like I've sent you an Excel data, okay, I've also sent you an SPSS data. You cannot start a data analysis. Straight away, you need to ask, I sent you the data, so I have to tell you what is the data about, what research or what kind of approach did we use to get this data? What is the meaning of every information within the data? We have to know all this before you can what? Do the analysis and produce results, because every analysis we are going to do depends on which design or which variables in the data. So this paper, we can even, let me go through the background. Late presentation with advanced HIV disease remains a significant challenge to human immunodeficiency virus, HIV care, contributing to increased morbidity, mortality, and healthcare costs. So despite global effort to enhance early diagnosis, a considerable proportion of individuals with HIV are unaware of being affected and therefore present late for HIV care. So for the first time in Ghana, this study assessed the prevalence of this late presentation with advanced HIV disease and associated factors among people living with what? HIV. So at least just the abstract will give you what this paper is about. Again, we have courses on effective scientific writing that we do. How to write this is also a whole training that we organize training for. Because writing is also a whole concept. How you write your introduction, everything is a whole thing. So you could see that with a good writing, even for background, it's going to tell you the brief intro to what your study is about, what problem are you going to solve, and what is the study aim. So it's telling us that, oh, this research is just focusing on, we want to assess the prevalence. So some one topic will just be prevalence and factors associated with people being diagnosed with HIV, then the person will publish. But in this current law, you see that such papers will not sell. In fact, this paper, as soon as we published it, within a month, it was cited. So that is the background. Okay, I will not even go to the introduction. So I will not come here. Later on, you can read and see how we even write this introduction. It's today, we don't have time to go through how to write and the rest. We just want to understand the paper. Then we look at some key concepts within it. So then that will tell you that you've defined the background of the work you want to do. Then you ask yourself, how are you going to do this? So that will lead to your methodology. So we come here, let me move here for more detailed analysis. So we have this, it was a retrospective cross-sectional study design. So we've learned study design, or if it's your first time, we have what we call study design in research methodology. Whether we are doing more of, we have different kinds of them. But one of them, someone can just say a retrospective. Retrospective is one of the cohort studies. And cross-sectional is also another one. So someone study can be only retrospective. When we say retrospective, it means that already the data is there. Like a typical example is in the hospital. You know, every day people go to the hospital and they are generating data. So those data are there. But if you want to do a research, okay, sometimes there's no need to go and recruit human beings or, for example, those in the engineer, let's say the mining sector, or those in the ECG, already they have records of the number of ECG kind of payment they are receiving. Therefore, they have data on everything. So if you want to do research with ECG, sometimes you don't need to go and ask them what is kind of your revenue pattern for this month. You don't need to go and monitor. You can go for their previous data and look at the trend of payment. Are people in the community paying electricity bill or something? But you know, one challenge in research is they'll be sensitive. Sometimes they'll not give you those data. But if you are lucky and they give you those data, it's called retrospective or study. So it's kind of a study where you just go back or go to any institution, you go and take their data, then you analyze it to become your research. Cross-sectional is more of real time. You recruit people right time, you study them, you collect data, and then you let them go. So that's also another design of the research. So in this study, what the authors did is they took both a retrospective data and they also recruited the participants. So their past history of when they were diagnosed with the HIV and in which stage they were diagnosed. And again, they also asked them right-time question. So it becomes more of a retrospective cross-sectional study that was done within Ghana. Then one aspect is you need to describe your population. So the data we are going to handle, what is the population? Where did we generate it from? Did we generate it from the community or from people in the hospital? So that one describe the kind of population that you describe. So in this case, the paper is just focused on the newly diagnosed individuals. That is first time. We want to see at what stage were they diagnosed when they were confirmed for the first time. That was the focus of the study. So it means that those that from the later stage, they are not included in the study. So it kind of you define what the population that you want to include in your study. So you describe them. At what age are you describing them? So this study was in adults. You know, in Ghana, adults are from 18 years and above. So if we are conducting a research, let's say in ECG, you tell them you want people, let's say 18 and above, they are living in the community, or people that have Ghana card, or people that have this. You kind of give increasing criteria to what? The population you want to include in your study. It means that those that will fall outside the exclusion becomes what? Your exclusion criteria. So after you define your inclusion, if someone fall outside within those ranges, it becomes what? Your exclusion criteria. And one thing we don't also forget is calculation of sample size. So in more kind of health methodological study, we have to define our sample size. We have different formulas for computing the sample size, depending on what? The study design. So for example, most either retrospective or cross-sectional study, we kind of use the Cochrane formula. So you can use either the Cochrane formula or what we call the Yamani formula. We use this formula when we have what? A previous population or prevalence within that concept of the disease of interest. So because this one deal with the Z and the prevalence, P squared in the formula, and the margin of error. So I want you to kind of cut across is that even the formula we use to calculate the number of people you want to include in your study, we have to prove it mathematically. So you just say that, oh, I'm going to recruit 50 people. in my research. I'm going to recruit 100 people. I'm going to recruit this. No, we prove it. And there are different kind of formula that we use. If you are dealing with a case control study, there's different formula, like the flex formula, the NCASIS formula. Those are also there. So the kind of study design or what kind of study we are going to do will depends on even the number of participants we want to what include and how we are going to what calculate what those formula. I know sometimes a lot of people, because of money, they'll try to adjust. I said, I'm going to recruit 40 people, but you have to prove it. And how are you going to sample them? That's what we call the sampling technique. And that will give you a more way of how are you going to just go into the community, give them questionnaire randomly, or how are you going to do them? There's different way, but today we're just going to have a snapshot of all these things. We are not going to details on research methodology and those stuffs. I have even recordings on only research methodology on our YouTube page, which include details of this. Then for human studies, okay, we cannot proceed without ethics. So this study took ethics from, because it was done in Kumasi or KNUXT, we have the ethics community that we took the ethics from. And for publication, we state the ethics number, kind of a referral number in the ethical consideration. Did you also take consent from the participant that want to include them? Then we now come to the data collection. So this is more of a questionnaire-based study, okay? So in this case, we design a questionnaire that includes every information that we want to take from the participant. So that one we kind of we describe what the population. So the data that you see in the Excel, this one, it doesn't come straight like this. First, what actors did is they designed a well-structured questionnaire. Then they went to the field and they took the data. Then they came back and they entered every information into the Excel. We'll come back to that. So you describe the data collection instrument, whether we are going to take, so today we are going to do some analysis on the socio-demographic variables and a few clinical variables. So the data I sent to you, lifestyle, I've taken off because we don't need them. It's just for practice. I've taken off some variables from the lifestyle, psychological factor. I've taken off all those things. So depending on how your research topic, then you're able to know that what kind of information do I need, either from the lab or the population, what kind of information. Then you have to put all those information on a structured form so that you can easily track all those things and you input it for your statistical analysis. Look, at the end, we need to gather those data very well for the analysis. Then, so the main thing of this topic is what? Late presentation with advanced HIV disease. But how are we going to classify those people? We need to also have a definition for it. So in this study, what happened is that those that were diagnosed straight at WHO stage 3 and stage 4, those were the people they defined as what late presenters. So if someone comes to the hospital and their first time of diagnosis, it is stage 3 or stage 4, they were called what? The late stage presenters. And automatically they have some advanced diseases also. But those that were lesser, like stage 1 or an initial stage, they were those that were that or late presenters. So that is everything about this paper, like background. I don't know if we have any question up to this stage. So that kind of the research design aspect. So as soon as we go through all these things, then data becomes ready. Then we understand. So the person is going to explain all these things to you. That that is the topic. Then I follow those all this procedure. This was my study design. Maybe these late presenters, I went through the archive, their medical records, and I took those data. Then I also checked their current age. I asked them what is their current age. I also asked them whether they are male or female. This one we are talking about sex from birth, not the current derived genders. Then you took the day, ask them, are you married? Then the person will tell you, maybe I'm married, I'm not married. Then you also ask them, what is your educational level? Where do you stay? Are you employed? What is the approximately monthly income? Even some people, it can happen that what time do you take to reach the clinic? So it's likely those that stay afar, they have to take a lot of transport, the very long distance for them to reach their clinic. So any information that you think will affect your research, because before we start the research, you've read through a lot of articles, you've done literature review, so you know some information that will affect your data. So you gather all those things, then you put them into what? A structured questionnaire. That's what we call the data collection instrument. Then this stage, you go to the field, you're able to take all those data. What is the type? So if you come to the case of HIV, which we are using for a case study today, we have different types of them. So you're able to see what type are these and what stage were they, and did they have any infections? A lot. So there's a lot. If you go through the paper, you could see that we have a lot of variables in this. But today we are just going to use few to do the practice, and that should go. Any question up to this stage? So this concept is applicable to any research you are doing, like how you are going to derive your background information, how are you going to structure the whole thing. I don't know if we are following, put one in the chat. The way we are, I want to make sure we are following and I'm not talking alone. Great, great. Yeah. Yes, happy we are all following. Yes. Yes. So you know your research better. So any research you are doing, as I said, we have different, we have uh, details presentation or in any aspect of the research that we do. If presentation or scientific writing, anywhere, we do all those things. But today we are just going to have a snapshot of all this research and data analysis approach. So for the first time, if we gather data, we input the raw data into Excel. So Excel is kind of the universal recipient. So although I sent you SPSS data, okay, we don't directly enter data into SPSS. I know a lot of people do this because they've been taught in class how to enter data, but we don't do that. We first enter data into your Excel in the raw format. So for example, gender, if it's female, you enter female. Male, you enter male. As it is like that. With the full name, you don't code it in the questionnaire and be entering one or two. The reason is we have to be able to what? Do data cleaning and coding in the statistical analysis stage. So if you go to the field, you come back. Okay, someone is asking question a little bit about the Cochrane formula. So let me just go back quickly. We'll come back here. So I will say we have different formulas depending on the study that you are doing. Okay. So for example, in this paper, we use what we call the Cochrane formula. The Cochrane formula is use the z squared. That is the z is the value of the identified confidence intervals. In fact, if you join our detailed training, I'll teach you all these things. How do we come about z value, t value, tell you all these things. So the z squared and the prevalence p, and the q is 1 minus the p-value. That is the prevalence of the condition, and the e is the margin of error. So we use the Cochrane formula specifically when we are doing more of cohort study, that is retrospective or a cross-sectional. And in this case, we know P is the prevalence. So for example, in this paper, we are talking about HIV as a condition. So already there's prevalence of HIV reported in another person's research, which was 1.7%. So in this case, we can use the Cochrane formula. But someone will say, I'm doing a research, but I've searched through the whole literature. There's no prevalence. In this case, we can use what we call the Yamani formula. The Yamani formula uses the estimated population. So for example, if you are going to take your data from Cape Coast Teaching Hospital, already they have the estimated number of attendance per month or per year. Then if you are going to take your data for within 3 months, you can take estimated attendance of those population per the month. Then you input it into the formula to estimate your sample size. Because that one will be able to tell you that, oh, if on average 100 people visit that hospital, then it will give you estimated what value that you are likely to get. That, oh, even at least you are going to get what 70% of those population coming. So the formula used in estimating your sample size depends on the information that you have and the kind of study design that you have. Because I said, if you're using a study design like case control study, you don't use this formula. If sometimes most clinical trials, complex studies, there's a lot of different formulas that we use. If recently we published a paper on the clinical trials, if we check the kind of sample size formula that used in that paper. So all this is defined. So I don't know whether we are on the same page, Elijah. Yes. So this Cochrane formula basically means that we have a prevalence of the condition. We are talking about condition because it's more of involved in the health conditions. But if you are in the social science engineering, you might want to look at what is the estimated what kind of people coming to the UCG or any other stuffs. There are different formulas that we use for them. Okay, thank you. So if you come here, I was saying that when you're able to follow all those methods, you know your background information, you know your methods. That is from the design sample size, you design your questionnaire. Then you now what enter the data into what? Excel. And Excel, we enter them in a raw stage. A raw stage. So type 1, you will type type 1. The reason is that, in fact, in data analysis, it's not just about what I'm going to talk about you today. We have what we call the data cleaning and coding stage. Data cleaning, you go back to inspect every variable in your data set to check whether there's a typo error. Is there any really abnormal value you've entered that is totally out of range? Then you correct all those things in the data. So data analysis is not just about using the software going back. It's about knowing the science, knowing what is in the data. Then you're able to correct all those things before you move towards the analysis. So if someone is entering the data in the raw state like male, female, and the person even make an error, instead of female, the person do a spelling mistake, you're able to correct all those things. Then you know that you are sure that you are working with the right data in the variable. Before that, let me even explain the difference between variable and data because I'm going to be using it throughout. We have this whole data set, okay? So as we've been using different names. So there's difference between variable and data. Because this is going to kind of, I just want to explain this briefly. So variable is kind of a whole set. So for example, let's just look at this. When we look at this Excel sheet, we have some stuff that are headings, and within headings, we have entries. So, for example, if you have gender, gender is what we call a variable. Then within gender, we have male and female. So male, female is what we call what? Data. So it means that within what? A particular what? Whole set, there's different variables. Different variables. So we can have a variable like LPAHT status, age group, gender, marital status. They are different variables. So these variables within it, we have unique what? Data entries. So specifically, we say what? Data is a subset of a variable. So in this case, in data analysis, we have to know what kind of variable do we have, and that will infer what kind of analysis we are going to do. So from that, you'll be able to do your coding. In fact, this is a clean data set, so there's no cleaning we are going to do here. Then you're able to clean encoding. But before that, you have to ask yourself what kind of software you are going to use to do your analysis. Today, I'm going to use SPSS. Already, I've sent you SPSS data. Then I also show you GraphPad. So for SPSS, it's easy to handle variables or data in what? Numbers. So after you've entered this in alphabet, it's reconverted into what? Numbers. That is the coding stage. So if you come to the SPSS that I sent to you, we have this switch between the alphabet and the data. So you could see that already I've coded it because we don't have a lot of time. I've done all these things for us to practice. So this is the numbers form of it. So the raw data was like this. Then it was clean and coded like this. Then it was what? Imported into what? SPSS. Then it was recoded to what? Become like this. Then we can now use it for the analysis. I'm just trying to explain everything behind it so that you don't get messy and how we got here. So depending on the kind of software, all your first data entry is in Excel. Then from Excel, we can then move it to any other softwares for your analysis. So later stage, you see George also uh, importing this data into R for you to show how you import it for analysis. Uh, yes, technically you should have paid for SPS, but in Ghana, mostly we don't have money for subscription or the institution. Most institution does not subscribe. Ideally, for example, if you're in K University, UCC or UG, they are supposed to buy the SPS so that students will access it free. But because of that, they don't do that. You have to get the crack version. So when we are there, I'll share my crack versions with you to use. But mostly if you come uh, here, like the US, all our labs, individual labs, we have a paid version, the PI. So you're like in Ghana, I say your lecturer will have a paid version for all the software so that their students will be using it. That's what they do here. So the PI or your lecturer has to be paying. That's what we do here. So all our labs, we have every software that we use, we have the subscribe, the original version that we are using. So, but in Ghana, I mean, up to now, every software I'm using is still the crack version I have. So I'll share those with you. So you have your raw data, you clean code, then you finally come to what? Your SPSS. So let's come to SPSS. Then we'll start some analysis from there. So before that, you need to know your variables, okay? So regardless of where background you are, whether you are from engineering, the health, social sciences, most of us use SPSS. So, but we need to know the kind of variable we are handling, okay? That will going to tell us what kind of analysis we are going to do. Yeah, okay, 14, yes. You can
Please,
talk.
I have a quick question. Please, you manually transfer the data from Excel to your SPSS, or is there a direct or which just convert it at once?
Again, let me.
Do you manually transfer your data from your Excel to SPSS, or there's a way to just convert it directly?
Okay, so okay, let me just demonstrate that. As I said, because of time, that's why I'm skipping a lot of stuff. So, for example, this data is ready in what? Excel. You have to bring it to SPSS. So what we do is that we import. So how do we do that? We go to File, then Import Data. Then we set from the data is in what? Excel. So I'll choose Excel. So we can import from other format like CSV format, text format, SAS, Stata. So with this data and other software also. But this data is what? In Excel. So you click Excel. So I'll click Excel. Then I'll look on my PC. So already I have a folder for this. So already I'll locate where. So I use this drop down to search for where I've saved my Excel what data. Okay. So I've created a folder on my PC for this training, research and data analysis clinic that have this data set. So I'll click on it. Then I'll say open. After that, I'll go over the SPSS interface also small with you for first time users. So I'll click on open, then it will give me a prompt. So I'm waiting for that. Depending on your PC, this PC I'm using for right now is a bit slow, but it will load it. So if there will be a prompt, I'm sure it's because of the PC. That's so by if you are using a high uh, performing PC, then it will load fast. Yes, yes, 14. So I just want it to load because there's another step. If not, I'll proceed. So when it loads, I'll go there. So that's the steps I was trying to demonstrate, but currently my PC is busy, so to come. So when we come to XPSS, before that, let me tell you that if you are first time to SPSS, SPSS has two windows, okay, when you launch it or when you install it. We have what we call the input window and the output window. So you see, when I put the cursor at the start menu, we have two of them. This is the output. If you do any analysis, it will come here. And we have the input window. This is where I am right now. So the input window is where you will see your data interface, and also you see your variable interface. So at your data interface, you see your variables become sort the columns like we seen in the Excel. Then your participant becomes your rows. Then with every information moving around it. So today we are not going to details on how to do all those things. We just want to appreciate it. Then we also come and see the kind of variables we have. So you could see that if you look at the variables, some of them come with different symbols. Some of them have this three dot with an alphabet telling you it's a string variable, or they have alphabet within them. Some of them just have just three circles telling you that they are purely hot numbers. Some of them also have this ruler, you see, telling you that although they are numbers, they are continuous. So before that, let me tell you that there are different kinds of variables. Broadly, we handle categorical variables and continuous sort variables. We have categorical. When we say categorical variable, a typical example is gender. You know gender, we have what? Males and females. Or those variables that come with what? Groups or levels. So today's analysis, we are going to do more of only on categorical variables. We are not going to tackle any continuous variable here. So But when we take these categorical variables, or those that come with categories, groups, we have two also forms. We have what we call the nominal categorical variables and what we call ordinal categorical variables. A typical example is gender. Gender is referred to as nominal categorical variable because you cannot kind of arrange them. Someone can choose to bring male first, someone can choose to bring what? Females first. There's no any order. But if you look at a typical example like the stage, HIV stage, okay, you know we move from stage 1 to stage 2 to stage 3. So it's kind of ranked. So that one, although they come with groups, we call them ordinal categorical what variables. So sometimes depending on the analysis, the intent of analysis, this also becomes important. So SPSS, for example, is able to specify those kind of variables under measures. So as I said, if you don't also know this, it's kind of you are going to produce a wrong analysis. So SPSS will further specify all those things. So for example, gender, it tells us that it's just a nominal. It means that although it's a categorical variable, it's a nominal categorical variable. But sometimes if you import data into SPSS, it can automatically detect it. But sometimes too, you need to further specify it. So if you look at HIV stage, if it's not specified, you can always click on it and specify that, oh, I want you to treat this variable as ordinal categorical variable, or I want you to treat it as nominal categorical variables. Then you tell the software. Because some analysis, if you don't do it, it will not work. But like I said, this is more of webinar. If you go into our full training, you see us talking about more of this into details. And if you look at continuous variable, when we say continuous variable, they are variable that can be only numbers. It can be either whole numbers or decimals. That will further specify whether we are talking about discrete variables or continuous variable itself. They all come into a broader umbrella, what we call numerical variables. But in the case of data science, we specify all numerical variables as continuous variables. A typical example is in SPSS, it specifies all numerical variables, whether it is a continuous variable, it is a discrete variable, is a ratio. So those that are doing pure statistics, you know, we have a lot of different variables. But in the case of this, we treat all of them as scalar quantities. We don't go into details, specify all those because all kind of analysis that we do, they are all treated at the same levels. So a typical example of SPSS, treat all those kind of numerical variables that you learn from your stat class as a scalar quantities. Because if we come to detailed analysis on the continuous variables, we treat them at the same levels. But we further differentiate with respect to the groups where we're able to see whether they are parametric or not parametric. But today we are not going to talk about all these things. This research paper is focusing more on what? Categorical variables. So we are just going to play around categorical variables for today. So SPSS is able to specify all those things. So you have to make sure that all variables are right. Everything is intact here. I've done my coding, so I'm not going to details on all those things. So that way, I'm going to skip a lot of stuff, then we proceed to do some simple analysis. So someone have passed through all those stages, okay, gather data for you. Then you want to what? Do analysis. What is the first analysis that you do? Mostly the first analysis that we do is to describe the population. You don't straight away and say how many people has the presented late or how many people did not present late. The first analysis we do is to describe the population. So if you look at this paper, the first analysis describes the population. Before that, I want to also tell you that the data in this paper is just kind of a snapshot of the total analysis. There's a lot of analysis that we did that we didn't publish, but we only publish the needed, because some journals will even have requirement that you are supposed to submit the number of tables, the number of figures. And again, some information are more of redundant unless reviewers require it before we submit. But other than that, we present only important data in the paper. But if this is a thesis work, in thesis, you can have up to 20 tables. When we do PhD analysis, we can even have only data analysis can be up to like 50 pages, because PhD, for example, they have a lot of data. But in publication, you look at what is the topic about and what data are we presenting to support the topic. What discussion are we presenting? That's the focus. So that's why you not see a lot of information in this data. But if you go to the person thesis, you see all those things. So first, we describe the population. So you could see that in the first table here, we describe the age. You could see we have age. Age as a variable can be treated in two ways. Age can be treated as one, a continuous variable, that is the raw age of the participant, or two, as a categorical variables. And I want to tell you another myth about age. So a lot of people, as soon as they are going to the ground, they already classify their age as age 20 to 29 years, 30 to 39 years, 40 to 49 years. No, we don't do that. We don't design questionnaire and do that. I would say it's not recommended, because if you go and you take the data, you come back, you cannot really have control over that group data. You come back, all your participants are all or majority are 20 to 29 years. You cannot do a further grouping on that. And it's going to affect your statistical analysis. The bottom line is how we create groups depends on the distribution of the data, not the interval of the group. So a lot of people do grouping based on interval. So they want to have equal interval, like 5 interval, 10 intervals. No. And we don't recommend that. We do grouping or category. So you could see that in this data set, every group that we've created depends on the distribution of what? The participants. So if a lot of participants are within 20 to 25 years, then some are within 26 to 29 years. Then few are within 30 to 39 years. Then we create a group 20 to 25 years, 26 to 29 years, then 30 to 39 years. Without paying attention to the intervals, like someone will say, I want to see that there's equal 5 interval, equal 10 interval. No, we don't recommend that, because the kind of group, if we end up having one or two group people in one group and having a lot of people in another group, is going to affect your statistical analysis. So age, some supervisors, they want to see their students present age, for example, as continuous variable. Some of them want them to present as age group. Some of them want to see both. So it depends on the kind of research you are doing. Then you create groups. We are able to do all this in SPSS or Excel. Everywhere we can create all these things. So there's a way we did all those things. That's why we arrive in the data. So we want to replicate some of the analysis. So for example, table 1 describe the population. So we've recruited participants, we've gathered data. We want to see what is the description. That's what we call descriptive statistics. So the first type of statistics we do is called the descriptive statistics. On the what? There's just the baseline data that we collected from the participant. You don't have to be confused. I've talked about different variables. There's different variable. That's what we call the numerical variables, the categorical variables. That's what we talk about. Then we have different kinds of statistics. Like we have the descriptive statistics and we have the inferential statistics. When we come to the descriptive start, it also depends on the kind of variable we are handling. Whether we are handling a categorical variables or continuous variables, it's also different. So today, most of the variables we are going to handle, they are all categorical, like they come in groups, like age group, gender, male, female. So we call them categorical variables. And the first kind of statistic we want to do is what we call the descriptive style. We want to describe the population. Then we have to do that. So to do that in SPSS, we go to analyze. So SPSS, any kind of analysis that you do is at analyze button. Already, I've told you we have two windows, the input window, the output window. Output will show you the results, depending on the software you are using and how it's used. But if you want to do analysis, you come to analyze. There's a lot of stuff we do in that transformation. When we want to create groups and the rest, we come there. Data, there's a lot of things we do there. But today we want to play around it to do the analysis in the next 1 hour. So we are going to, do you have any question? I think I've been talking a lot. If you're with me, put one in the chat, or we will have 3 minutes break to refresh the mind, then we come back. And if you're following, put one in the chat. Let me see that we are all following, yes. So let's try and refresh our mind in 1 minute, 3 minutes, 5 minutes, then we will come back. So it's yes. So we will come back at 5 minutes time. Great, great. Happy that we are all following. If you have any question, anything, you can put it in the chat, any stage, or you can mute to talk as we go on 5 minute break. Any question? So wherever you are joining us from, we appreciate you joining us. Yes, we appreciate you. We have different time zone. So for me, I started the training at 6 a.m. here. So it's now around 7:11 a.m. here. So it means we are all sacrificing our time to meet. Some of you is already after there or something, yeah. We're happy wherever you are joining us from. So our page, we have diverse page. Anyone from Nigeria here, put in the chat. Let's see you are here. Yeah, so someone is asking a question about coding. Yes, then let me address that. So in respect to coding, I said I've tried to skip a lot of stuff. Yes, so you code data depending on your choice. So for example, if I will always tell you that for scientific community or data science community, we always code yes or no responses with 0 and 1. So we use 0 for no, yes for 1. So in that case, we usually code if you have a lot of variables that are coming with yes or no, easily. So if someone send me data without any scripts, I always say that, oh, yes or no is kind of 0 and 1. So for example, but this data, it was coded different, which is yes for 1, no, yes for 2, no for 1. That was how this data was coded. But I always recommend that no 0, yes 1. So it depends what you choose. But the reason why I'm saying is that when we are doing prediction models, like the logistic regression prediction models, specifically the binary, we try to predict for the disease state, the positive. So in that case, if we happen to code for the positive case, like with the highest number, like here, the yes was coded 2. In binary logistics, I think that we try to do binary logistics today. It will predict automatically for the highest coding number, that is for the 2. That's what is going to happen. Yeah. So you are right if you code for two, but coding two for no, one for yes, it can affect your analysis. Okay, especially when we are doing prediction models. It means that your story is more of no, no, but in scientific community, we want to code for yes. Yes, yes, someone from Nigeria, you are here. I don't know whether you are with me. Yeah, someone. Uh, Kudos for joining us. So we always have a lot of people from different countries also joining our webinars. Yes. Yes, so that is the response with respect to coding. Yes. But you understand all this better when you kind of we go into details uh, in how kind of analysis work. Then you kind of make choices that you get to know that coding two for no is a bad decision, and one for yes is a bad decision. It's going to affect your analysis. Yeah. This if the yes or no is being coded, does it mean with our interpretation we will have to provide a key for those variables? Yes, in fact, if from coding, okay, whatever you see here, if we are coding zero, like any variable here to this stage, right, there's always a key. So if I wanted you to code this in the SPSS, I'll give you the key. So it's not like we start entering numbers. We have key for everything. So as you are doing your coding, you keep your keys. You keep your keys. So I think this data I didn't send the keys in addition. Okay. But assuming if you are the one code, so for example, male, you want to code male as one, females as two. You keep those keys because you are going to need them. That's why we use it to recode it. So for example, if you come to this data, females were coded one, males were coded what? Two. Because the data is already recoded. That's why I didn't send you the key. You might not need them. So yes, John, we have social media pages. Thank you very much. We have social media pages. You have to follow us. I'm sure, yes, they'll be dropping our social media pages. Yeah, our media publicity head, Paul is always with us. Paul will be dropping those things on the pages. Then you can follow us and also follow the UCC SRC for future interesting way. Especially Mr. President Brown Normal always come with a lot of great initiatives. So wherever you see any of us, you can follow us and our social media pages and to interact with our future events. Yes, you're always welcome to join us. So our break is almost over. It's like we use the break to even tackle questions, which is good. So keep your questions flowing as and when so that you get any clarification that you want. We are always happy to help you to learn together in our future journey. So at this stage, we've talked a lot about some science basic background. We want to just do some practice and zoom into how to use the software, one or two, then we are good to go. So this is first, we want to look at how did we come about the age group? How do we do the analysis and say that? First, I want to tell you that the total population in this data is 350. So how did we do the analysis? Then we're able to see that how many people are within 18 to 35 years? How many are within 36 to 45 years? How many are within? Then we presented it for publication. So this is what more of a categorical variables throughout. So I'll go back to my software, as I said, analysis. And also at this stage, I don't really teach shortcut. There's shortcuts to a lot of stuff. In fact, you never teach the shortcut, but always is good to learn the first step. So you come to analyze descriptive stats. Okay. Analyze descriptive stats. So anything. So there's a lot of things we do here. A lot of stuff. So most often you will never stop learning. In fact, there's no field that you add that you finish learning everything. No, no, no. There's always a lot of things you never. So, but basically, we have as you know A, then you build on to B, you build on to C. That's what we do. So, descriptive start, then you come to frequencies. Frequencies has a lot of tabs that we can work on. So, for categorical variable, the descriptive start is very, very easy. So you just move it, let's say age group. You see this data I sent to you, it already has the age group. Then I'll move age group inside. Let me see the chart. Okay. So I'll move in, you just move in the age group. So this is age group. So for software like SPSS, it's kind of click, 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 click. That's all. When you move to the I, you know that you're writing scripts. But here, the nice thing is that it's clicking. You just click on the variable, then we move it inside. Then for here, just the script, we just make sure display frequency table is tick. That is all. No need to go here. We'll come back. This is tick, then you click OK. Then it's going to give us what? The result. Again, I'm going to repeat that. This is just descriptive start on a categorical variable. If you are doing descriptive start on continuous variable, we go to this different paths or different approach. So we come to analyze descriptive stats, then frequency. Then the group or the variable we are interested in is what? The age group. The age group was here. I just move in age group here. Then I click on display frequency. Then I click on OK. That's what I did. Then you remember I said we have two windows. The input window where you were able to see the data and the output window. So this one will give you the results, telling you that how we coded the data. The data was coded this way, 80 to 35 years. Then it produced the results. So we have the frequencies. The frequency talk about the actual people, the numbers within the groups. Within the groups, then we have the percentage and the valid percent. We need to produce the results. So sometimes you see people reporting wrong figures, especially percentage in the data. Sometimes I'll see people's analysis, I was like, no, you have to go and redo the whole analysis. I will read for a lot of journals, especially if you publish in BMC, Nature, and those things. It's likely you see me review your paper. You see that sometimes it's very unfortunate that I recommend rejection because there's wrong statistical analysis, which is beyond control. But it's good to always report. Sometimes, if they are missing data in your variables, you will see the percentage and valid percent will be different. The difference between valid percent and percentage does not account for the missing participants. So the valid percent only talks about the valid participants that is in the data. So a typical example is, let me do another analysis on where we have missing variables. Let's say this variable monthly income. You see, there's one participant that was missing. Let's do analysis on that and see. Analyze descriptives. I'll move. You can choose to move in a lot of variables also at the same time. The analysis will come together. So I want to do analysis on monthly income. Let's say I want to add monthly income to it. So I click OK to analyze everything together. So for descriptive stats and the rest, you can move all the variables together, analyze, then the result will come together and a report. But if we are dealing with an inferential stats, we can analyze data together, except we are kind of adjusting for co-founders. So let's see what I mean on the reporting of percentage. So you could see that here, there was one missing. In fact, because of time, I've not talked about how we handle missing data and the rest. Just giving you a snapshot of some entries. So you could see that this one, there's one missing participant. So that tells you that the percentage and the valid percent, there's slight difference between them. So in this case, in reporting, we always report the valid percent. So valid percent, because we want to see the valid participants, that is without the missing people, out of the reported people that you took data from, what was their percentage, the estimated percentage. So in this case, we're able to report that, 18 to 35 years, we have 41 people and the percentage is what? 13.0%. And you see that it has been reported what? In the research paper. Then you're able to report all those. So that's how this table came about. So the analysis, that's just analysis we did in all those variables. Then we came about that data. Any question up to this stage? So for example, if you want to do analysis on the marital status, so the same thing, you go to analyze descriptives, frequency, then let me just move in marital status. Then we analyze and report. As I said, before you do all these things, then you know what you are doing, what kind of analysis you are doing. Then you can now what report. So you do all these things, then you report. So if you look at the paper, table 1 talks about all those things. We are just describing. So this is what we call descriptive stats. Out of the participant that you recruited, okay, someone is asking a question. Please, does SPSS interpret analysis done for you, or it has to be done by the one doing? Yes, exactly. So for any statistical tool, it just gives you the result like this. Okay. So it means that you have to understand. As I said, you have to understand whatever you are analyzing, then report. So everything that you see here is true what we wrote all these things. So I would say that of the 315 participants enrolled in the study, 1/3 were within the ages of this. 1/4 were within this range of this, with a least percentage of this. Most of the participants in the study were females, with males accounting for. So this is you after you've done analysis, you are going to write all these things. But don't worry, research is a process. You don't have to jump and no. It's stage by stage. So that's why if you happen to join different training in a systematic manner, then you're able to learn all these things that we are doing. So if you use any analytical tool like SPSS, you're only going to see tables, result like this. In fact, we don't also even directly report data into Word document. We have to report these results first into Excel. So there's a way we report all these things. I'll first report this into Excel. I'm going to use gender for instance. So I'll first report everything. So this result I had. So it's a journey, okay? This result that you get, you first report in Excel, then there's a way we send it back to Word. So again, someone will say that, oh, my PI or my supervisor said I should use SPSS for analysis. So as soon as the person finished the SPSS, the person will copy all this thing like this and go and copy, paste in the Word document. We don't do that. Yes, there's a way we do all this reporting. So for example, variable, we have, so variable is gender. That's the first one. Then in this case, we are already reporting the frequency. So there's a lot, but it's you don't have to know everything today. Okay, as you join more training, you get to know a lot of how to do all these things. Then we have the percentage. So there's a way we prepare what we call a PA table and a lot. So you have to report your results. Okay. So what is gender? Gender. Okay, let me do analysis on gender. Or let me just use the age group. Again, unit is very important regardless of your field. If you don't report the unit of a variable, no one will know because everyone in the unit, you cannot report anything that has a variable without reporting the variable, the unit of the variable. So you report all these things. I report all this. So there's a lot, and we try to learn together to advance each stage. Each stage, that's what we do. And you're able to learn more with time. So you are going to port all this, then you port all this like this 105, report all these things. Then you report the percentage. So this what software is going to what give you, okay? But in the interpretation, the understanding of the result, what you are seeing, you have to have the scientific eye, the data science eye, the everything. You know the research better. So you have to tell them this is what I'm seeing. Like you've seen the topic, high prevalence of this. So is it true? It's you. So we got to know it's from the result that we know that, oh, there's high prevalence on that topic. So it's you that is doing all those things. This is all what you get from analysis. So the rest is for you to do the write-ups. Then we are good to go. Now, so that is the description of the results. You describe, so the first one is going to describe all what, everything for you, describe everything for you. Then if you're able to do that, then the next one is you want to now talk about your what, dependent variable. So we have what we call dependent variable and independent variable. Let me also just briefly tell you that in every research, at least there's one dependent variable and the rest are independent variable. In a complex research, there are some variables that can be dependent also variable. So in that case, this study, for example, this is our dependent variable. And every other thing you see here are independent variable. Because this variable, they are depending on this variable to behave. With different changes in this independent variable, this dependent variable is going to change. So that's what we call factors that will be associated with the dependent variable. Yes, you have to manually type the result from SPSS to Excel. So there's a lot of work. So it's a lot of work. So analysis, some complex data analysis can take you a week. So someone can send data, one analysis within 1 hour. This it means the person either really don't know what goes into analysis. So after you've done the analysis, you have to type everything manually into Excel to prepare your table before you move to your Word to prepare your APA table. Yes, so now we want to see how many presented late and how many did not present late. One, we can do the analysis in what? SPSS. So we go to analyze descriptives, then you move everything. Then let's say this is a dependent variable. So now we want to see overall how many presented late and how many did not present late. Then we analyze. It's going to tell you that overall late presented, yes, we have 28.6% and 71.4%. But you can know this is your main group of interest. So if you come to this data, this is the figure. This is your main variable of interest. Like you should be able to tell them that over all the 315 participants that I recruited, the LP people were what? 90. That corresponds to 28.6 percent. Then you have that from what? The data. But in presentation, you cannot just prepare only table for this because you want to present them that this figure are the oh this is what this is what it is. That is what we want to what, use graphs. So being able to determine which of my data am I going to use table, which of them am I going to use graphs is also another thing. Now, if you come to the SPSS, right? SPSS, we can also do graphs. So for example, this go to graphs, legacy dialogues, let's say bar chart. Let's see what is coming here. Simple. Then I want to see just category as is, number of cases. Then okay. Let's see. So this is what SPSS will tell you. But do you like this graph? I don't know if anyone likes this graph. If you like this graph, put one. If you don't like it, put no in the chat. Who like this graph? Yes. So this graph is really weird. Like, yes, even this. So SPSS has a limitation. That is one. The graphs cannot really. You can add a lot of information. Yes, it's not nice. So for example, if you look at what is in this paper, you see you're able to edit it to make it nice. Even add these features on top. Add all these things. That is where what we now move to what a different software. So although SPSS is able to do a lot of things, basic descriptives, if you ask yourself, can it do visualization? Can it present a beautiful graphs? This is where what, depending on the demand, what you want to do, we now move to other software like the GraphPad and what, the R language. So we now come to GraphPad. Let me move. So I'm going to plot this in a GraphPad to see. GraphPad is very, very simple. Like everyone can use it. If you are first time, as soon as I finish demonstrating this thing, you can even easily use GraphPad. So especially the aspect of your work that demand graph, then you can what, easily use graph. So it means that if you know only SPSS and GraphPad, you are done. You can use it to do a lot of analysis. In fact, if you go to a lot of research labs, here, GraphPad is the basic software that you see in every lab, every result, every data. First analysis, you go to graphs. You want to see how your data is looking like. Then you come to graph because GraphPad is able to what, easily do some of these things, easily want to do some of these things. But if you want more enhanced beauty, then you go to our language. So that will be the next software. So we just, because of that, we just want to now demonstrate this also in GraphPad. Then we see what will happen. So if you launch GraphPad, this is the first interface that you see, okay? And GraphPad will first make you select what do you want to do. Then it gives you
Hello,
pre.
sir.
Yes, yes, you can talk. Yes, hello. I think someone was. Okay, let's proceed.
Yes, so please, thank you very much for the presentation so far.
Okay. I think the line is breaking, but you can proceed. We can hear you. Okay, his network is unstable. Sorry for that. Probably when Timothy comes back, he can proceed with the question. So what I was saying is that when you launch GraphPad for the first time, GraphPad is very simple to use, so don't be. SPSS, we've not gone anywhere, but later we learn more about it. But GraphPad is very simple. If you want to do basic graphs, everything, you don't need to go and do graph in Excel anymore. At this stage, if I see a figure in Excel, I'll just ask the person, at least you have to use the basic software to do your graphs is GraphPad. So it will tell you this X and Y axis. This is more of when we have data and we do repeated measurement. Then we can use this approach. But today I'm just going to tell you the column approach. This one can easily let us do bar chart. So it see that it even give you samples, treated and controls. So it easily makes you do those kind of graphs. So we are just going to use that approach for today. Yes, Ralph.
Hello. Thank you very much, Chineben.
Yeah.
Yes. I have two concerns.
Okay.
The first one is when you are presenting your data in um, percentages and the frequencies, you made mention of the percentage and then the valid percentage.
Yes.
That is my concern. I think that if you are able to do a thorough data cleaning,
Mm-hmm.
you can still use the percentage. You were talking about the fact that when you are reviewing articles or papers, you always want the authors to use the valid percentage. That is the first concern, please.
Yes. Okay.
Then the second concern is about um, reporting your output window.
Mm-hmm.
Anytime I use SPSS, I see it like moving it to Excel and then to Word format. I see it as a waste of time. That is to me.
Yeah.
But I just do it straight away
You
from
copy and
SPSS
paste.
to not necessarily copy and paste,
Mm.
but I look at it and I present it in my own way, and it looks very nice, just as in articles. So I don't know whether that one is also right. Thank you.
Okay. Thank you. So the first one is the reporting. Yeah. So for example, if you're able to do your data clean, so for example, the first this analysis, you see this one does not have any missing entries. So in that case, whether we are talking about percentage or valid percent, is the same result. So in that case, if you're able to do proper data cleaning, as you said, in that case, proper data cleaning means that you don't have any missing data or missing entries in your results. So in that case, you still have the same percentage and valid percent. They are the same.
Exactly.
So you see that you are reporting percentage or valid percent. It's the same thing. So we have 17.5, 17.5. But to prevent people that will just focus on percentage and the rest, and at the end they need to go and report the results, I just said just pay attention to the valid percent. For that one, is going to give you a good percentage, regardless of either there's missing entries or not. So that's the baseline concept that we are using. Because that one will just account for all the missing entries that you have. In that case, you don't need to go back and redo analysis. And we specify that, oh, these are the variables with missing entries. That's what we recommend. So it's fine if you're able to, you are sure that you don't have any missing entries in your data, everything is right, then you'll be getting the same result like we have here, marital status. Their percentages are the same. Whether you're paying attention to percentage or valid percent, is the same thing. With your second question, that you're able to move data from, because at the end, we want every variable. So you could see that, let me show you. Okay, let me show you there. I should have, yes, let me show you the Word format of the paper that we publish. Okay, so you see how we prepare the paper or in a Word tool. So let me show you the table. So the article you see online, this is how it is in the Word format. So you see how APA table looks like. So in the case whereby you are bringing data straight from SPSS to here, how you are going to organize it to make sure, because we want to make sure that if you are talking about social demographic variable, they all come in one table. We don't have about 50 tables. Then you see one table for age group, one table for gender, and all. We want the result organized. So this is what we call APA table. So if you see all those top journals, you see tables like this. So it depends on how you're able to bring everything back and reorganize like this form. So you could see that go to the next one, we have the social demographic predators. Then we have them all in one table like this, nicely like this. So as soon as someone see your work in the Word document like this, the person becomes happy. It differentiates from the rest that are just playing around anything. I don't know if it depends on how you are organizing your results. Yes, we have session on a whole results presentation. Then we are good to go.
Yes, please, Sineben, please. Yes,
Okay.
I'm
Yeah.
I'm able to do it in the APA table, just like as you have presented.
Great, great, great. So then it's fine. It's fine. So I'm assuming that does not really take a lot of time. But the bottom line is we should avoid those that just paste this one straight, then like that. Paste straight in the Word without anything. But you should be able to work with the APA table. So the most recommended way is you have to really bring your results into Excel, then you now go and reformat into your Word. But any approach that you follow, the bottom line is you have to get your results nicely presented. Then everyone will be happy with your work. Yes. Thank you for that question. That was good. Please, we are all following and we are all on the same. So let me see the next one. Can you take us through how you do with Excel data, how you transfer it to the Word with? Yes, yes. So for example, let me just quickly design APA table for you. So for example, let's say this result is what I just did. Let me go there. This one. So at the end, you are going to have a lot of them, a lot. So more variables. Let's say variable A, you'll be having gender, male, female. I'm just going to show this. Then let's say you have any percentage. Okay, any percentage there. So at the end, you need to what? Send everything, okay? To your Word. So what I'll do is that you just select everything, then you copy, then I'll now come to my Word. So I'm just coming to show it here. Then I'll paste it here. Then we can now format it nicely. So it will be like this. Then you can now extend, you can do anything that you want. So this is more convenient, it easily do a lot of stuff on it. Then you can change anything. Maybe you want Times New Romans, everything in the table. You want to increase the font size. I want the table to be centered. Then I can also change the borders. To change the borders, I'll click here. I want to increase the border shadings. Maybe border shadings, mostly I want to use 2.25. Then I can now apply those borders to the down and also to the top. Like very simple. So this case, you don't do a lot of editing, copying straight from the SPSS. Come and do a lot of editing here. So within a few minutes, you are done preparing your table. So this is all we do. Then your result becomes so nicely arranged for you. So the only time wasted is you typing the results to Excel. Then after that, you can organize it in anywhere that you want. Then you're good to go. So that's how we bring the result to the Word doc. Don't know whether we have more questions. Please, I can't see the Word document on this. Can you see the Word document now? So for the software, we will share with you later. Yes, Ralph. Yes.
Yeah, Sinene, please.
Yeah.
Are we doing only descriptive statistics today? You're not talking about the inference too.
Yeah. I think because of time, yeah, almost like behind of time. I would have talked more. In fact, so probably if you happen to join our trainings, you learn more. Yes. Yeah. So I just want to so let me first also show the figure and graph part. Then let's see what happens. But there's a lot of stuff we have to do. And always for webness, we don't really have a lot of time. Is anyone else able to see the Word document on my screen? You should be able to see. Or it's only Mike here. If you're able to see my Word document screen, put one in the chat. I want to see. Yes. Okay. Okay. So I think Michael, you should be able to check from your end. Yeah. Okay. Yes. Great. There's a lot of stuff for us to do, but with time, let's see. So I'm just going to show how we do the bar chart. So here we can use this approach. This one give you using the column approach. You just click on the column. Then we have this interface, okay? So GraphPad is very easy to use. So I'm just going to use the same heading, no LP, or I'm just going to say no LA, LPAHD, then LPAHD. Then in this case, so one thing about GraphPad is most often we use the descriptives. So that's why mostly you cannot deal with GraphPad. So it's better you deal with the two. But if you want to bring the raw data, that one is mostly we copy and paste the raw data here. But what we do is that I'll just input the frequencies from my SPSS because we only need the frequencies to redraw our graph. So I'll go here. So you could see that we had what? It's either I'm using the frequencies or the percentage. So I'm going to use the percentage, which is very convenient. So no LP is 71.4, 71.4, then 28.6, like this. So if you're able to enter this, so GraphPad is very easy. So people that present data, they've already summarized it. The best statistical tool to use is what? A GraphPad. So you see here under tables, we have table 1. Then you've entered here. Then you could just see under graphs. You just click on graphs. It will present the corresponding graph for you. That is all. So here you're able to select which of the graphs you use. Then we are using the column. Do you want this graph or do you want it to be like this? So presentation of results is also a whole seminar that we have of its own. When do we even present data like this? When do we present like this? What kind of figures do we present? It's all different stages. So maybe I just want this vertical kind of graphs. So this is the first one. But the interesting thing about GraphPad is we can do a lot of stuff about it. We can enhance the size. So first, I can just come here, format axis, ranges, or take columns. So it's going to open. As I said, this PC I'm using right now, it's almost full everywhere. So it's a bit slow. But if you have high quality performing PC, it will come. So I just want the shapes. Mostly I use 4x3. So I can just quickly change everything to 4 and 3. Then I said, okay, it will retain the size for me. Then I can label the axis. Maybe here is frequencies into bracket percentage. I want to label like that. I don't need data one as heading. If you want this, you can also add it. Let's say LPAH status, you can add it. So whatever you want, you can add it. Then the nice thing is we can also change the colors. Then we can put every information on it. So most of publication, you see a graph with a lot of information. Mostly we do it on GraphPad or R language. So we can change the colors. I can double click on it. That's the short way to change the colors. It's going to open the prompt for me to justify or select my color of interest. So from here, so default is black. I can fill in different colors of my interest. So your favorite color, you can select any color. And this is filling, then I'll say apply. Mostly I want the fill and the border to be the same. I can select it, then I apply. So this one gives you a better interface compared to SPSS that you cannot change even color, anything. That's the limitation. But SPSS will do a lot of every analysis apart from visualization. So if we are doing visualization, then we move to a different softwares. So it depends. There are complex analysis. If we come to our field, molecular biology, where we do genomics and the rest, means those kind of analysis we only do in R or Python. Those are, so it depends on your field, but most often the basic software are this one. So you can change all these things. You can put the frequency and percentages on top, as we've done in the published paper. So I'll move here, then no. So to do that, you see here, we have text, write text. I'll click on just the text, then I'll put the cursor here. Then the no is 225 into bracket 71.4%. For some supervisors, they want to see all this. Then into bracket 28.6. So there's a lot of graphs, there are a lot of features, but today we are just doing a lot of stuff we will do. If you happen to join most subsequent trainings, you see a lot of features that we'll be doing. Then we can get a nice graph. Then you can now export this nicely, then you present in your figures. There are two ways to do this. Sometimes you can just copy. For example, you can right click on this, then you copy this and come and paste in your Word document. All of them has advantage and disadvantage. So for GraphPad, if you do a graph and you just copy and paste like this, okay, and you send your work to someone, if the person is also having a GraphPad, The advantage is that the person can also double click on this. The person can double click on it like this. Then it will open a prompt in a GraphPad. Then the person can even do any further edit. Maybe it was just a typo error. Then the person will do the editing. After that, the person will save. That is the advantage of the copy and paste method. But it makes the GraphPad figure editable. Said that if you did a typo error, a minor typo, like maybe the person wants different spellings, then the person can do all those things and it will save a stress for you to redoing those editing at your end. Or sometimes you want to import high quality. So for example, most journals requires that you need to submit 300 DPI figures in this format so that we can export. You can click on this export. Then we have to select where we want to save this. I want to save it in this. Then I'll select the folder I want to save it. I want to the name. Then here you can save it in a different format. EMF, EMF plus, there'll be a PDF, yeah, TEF, JPEG, PNG, anyone. So mostly we save depend on the format you select JPEG. Then you can now have the resolution, the DPI. You can select the required DPI you want, either 300, 600, 1,000. It's going to resolve it more for you. Then click on OK. Then it will resolve it for you in a very high quality format. So in that case, if you now click on it, you see the difference. So it depends on what you want to do and the approach that we use. Then gives you what very high quality format. So as soon as someone sees this, you see that this really enhanced figure to suit publication in top journals, or if your supervisor see you presenting this kind of figures, become more interested in your work. Although you are presenting great review, the result does not look nice. As soon as I presented something like this, people see that, yeah, you know quality work. Let me see screen questions. Yeah, so people use Power BI for visualization. People have been doing that, but I don't use Power BI. Okay, especially dashboard creation and those people are using it for crazy things. Yes, but I'm a GraphPad R bias. So these days I only use R for a lot of visualizations. And there's a lot of feasibility in these softwares, but Power BI and those things, all of them come with the advantage and disadvantage. As George will be taking you through R shortly, and right. So because of time, we may not do a lot of stuff today. I'll take questions at this stage, and yes, probably I'll just do one analysis on chi-square text. Was have demanded for one. So yes, comfort. I'll be back soon. So let's say, for example, the result that we've presented. We want to see how does age influence what the LPAP status, the late presentation status. Then you ask us what kind of variables are we doing with? So in this case, LP status is a categorical variables, and also age cut is a categorical variables. So in this case, if you want to do inferential stats, the first inferential stat we do is what we call chi-square. So if you join visual training, I'll tell you that in inferential stats, we are interested in differences, association, and predictions. So for differences and association for categorical variables, we use what we call chi-square test. So let me do chi-square test for you. So we have analyze descriptive stats, then you come to crosstab. That's what we do. Then mostly I want my dependent variable to be the column, then the independent variables will be the rows. I'll come to statistics, then I'll take chi-square. In future, I'll tell you the difference between when do we use chi-square and when do we use spatial results. So there's a lot of stuff, and today time will not allow us to do all those things. So I'm just interested in row by columns, then I will take. What does inferential start do us? Inferential start is only giving us p-value. So it tells us that, oh, age group. So you could see that it comes with the Pearson's chi-square and Pearson's chi-square value. So if further you have to understand what is even hypothesis testing, what is two-sided hypothesis, what is one-sided hypothesis. So there's a lot of stuff which time will not permit us today. Then you're able to report your p-value 0.002 for your work, and you are good to go. Okay, questions. Let's start from comfort. I saw comfort hands first. So it's a lot of interesting stuff that we can do if you come to data science. Comfort, you can mute your mic.
Thank you. Good afternoon,
After
and thanks for the presentation.
welcome.
Please, the data entry side, you said something of whether the data is categorical or nominal or ordinal. So I want to find out, in a situation where you are dealing with the data where you have boxes to check, as in more than one option. How do you put that data or go about it?
Exactly. So
And
that's really good question. Yes. So that's really a good question, and because of time, we will not be able to go through all this. So those kind of sub-level or multiple choice questions to ease complexity in data analysis, because if you enter all of them together, at the analysis stage, we have to still split them. So you have to create a subheading. So let's say factors. You have a whole multiple values on factors. Let's say then you have list of options to select. Maybe where you stay, and some people will select more than one. So in entry, you have to create what? A heading for all the responses. That's what we do. So you now create headings for all the responses. Then, for example, response one. Let's say response one, some people will select. Then those that will select, let's say we say yes for them. Some will say no. Some will not select. So all those that will select response one, you show yes for all those ones. Let's say response two. Some will select response one and response two, maybe yes for them, like that. So that's how we enter data for all those ones. So at the end, all those sub responses will now also become a main heading or main variable to ease analysis, because at the end, we are going to handle the analysis in those stages so that we're able to present descriptives for those that select response one, descriptive for those that select response two, and if we further do differential start for them. And again, we further even do what we call scoring. So we have grading and scoring, where a practical example is those that are doing knowledge, perception, those kind of CAPE questionnaire. We can even grade them and see those that have adequate knowledge, inadequate knowledge, and those things. So that's how we do them. I don't know if we are on the same level, Comfort.
Yes, please. Thank you very much.
Welcome. Yes, TA. You can unmute and talk.
Hello, sir. Good afternoon, and thank you for the good work.
Yes.
Yes. My first question has got to do with the proportion or the percentage you presented. Realize that it is like a point estimate, and usually in constructing point estimates or in estimating maybe prevalence, we are also advised to construct an interval estimate. In this case, a confidence interval around it.
Yes, exactly.
Please,
You can do all those things. So we can
do that.
Yes, you can always construct the 95% confidence intervals. Because of time, that's why I'm not going through all those things.
Okay. And
Yes,
okay, thank you.
yes. So in
And
that
then
case, they will look at the ranges from the estimate point. So it
okay,
depends. So those that actually those that are in social science and they like those kind of estimates in addition to the point,
that's
which
true.
is really nice, really nice. Yes. But in this kind
Okay,
of,
and
you could see
secondly,
that in this paper we did not present that because we are just interested in the health and the proportion that's associated with it, which is great.
okay, sir, thank you. And please, can I also make a contribution to the lady's question?
Exactly. Yeah.
Okay, with I think with that instance, if we know that we'll be handling multiple selects, you know, a data collection platform like Kobo Collect
We split
actually
it.
does a good job when it
Ex-
comes to
Those that
for
exactly.
Google.
So,
So we can encourage that they use that is if they can.
yeah.
Yes. Yeah. I just wanted to say that there's something like that
Yes.
because
So
Google Form will not do it.
yes, exactly. Apart from
Yeah.
Kobo Collect, there's another platform. I think Survey Monkey. I've not really.
Yeah.
So most of this online database automatically is going to split it for you, and it will make data cleaning and coding very easy. But those that will go for the data using a well-structured questionnaire, you will have to enter the data in those ways. But a lot of people who don't take data with the online form. But if you happen to design an online questionnaire, it will solve all these problems. Other than that, that's how you enter the data. So thank you for that. Yeah. And any more questions from? Okay, if not, Nicodemus, you can proceed.
Thank you very much, sir. My question has to do with in SPSS or this statistical data analysis, does it detect bias in your data?
Bias in both sense. So, for example, we have what we call validity and reliability testing. Let's say you've designed a questionnaire and you want to use it in your population. The first thing we do is reliability and validity testing. Okay. In that case, when it comes to reliability, we have what we call the Combrack alpha testing. We can do all those things in the software where we come to scale and we do all those things, reliability analysis.
Okay.
So the bias in such a way that you have a unless you want to do particular analysis to determine those bias. But it's kind of, you cannot just do a chi-square and it will tell you there's some kind of bias and all those things. But those kind of reliability testing, Comba Alpha, we are able to do all those things. Those are some of the advanced analysis that we do. I don't know if that's what you.
Okay, thank you very much. Yeah.
Yes. So we are able to do all those analysis in SPSS. Okay, yeah, comfort.
Thank you once again.
Okay.
Please, in a situation whereby you are concerned about your number of respondents, and you also find out that there are some missing variables also, or missing data in your data set,
Yes.
do you just leave it away as in discard it, or you still include it and then indicate the portions of the variables that were not responded to?
Exactly. So that's why I said initially, because of time, I didn't go in more into details of handling missing data. So the main concern in your data analysis is the dependent variable. So for example, our data of interest is LPAH status. In this case, at any means, someone has to be no or yes, or someone has to have this present late or not. Other than that, all the independent variables are kind of could be analyzed even if they have what missing entry. So for example, time to reach clinic. In that case, the analysis is going to be done on the valid participants. And then at the end, as we said, we indicate these variables as missing hot participants. That is the reason why we also recommend that you report the valid percent so that it will account for the valid participants, and you are good to go. But there's different stages of how we handle missing data. But baseline, this is what we do, which you are good to go.
Thank you.
Welcome. Any more questions? Yes, Raf. Yes.
Please, you didn't touch more about the inferential statistics. I don't know. I have a question, if I can ask.
Yes, you can ask. Yes.
Yes. When you are analyzing logistic regression analysis, you see, normally, when you are presenting the table, normally we do present the crude oil ratio under the univariate logistic regression.
Exactly.
And then the adjusted oil ratio under the multivariate logistic regression. Is it always the case? Is it always the case? Because sometimes I don't know whether it can be interchanged. Is it always the case?
Yes. So it's always the case, as you said. So when we talk about univariate logistic regression, those ones, the bottom line is that we are handling each variable independently. So for example, it's because of time. If I'm supposed to do a logistic regression, in this case, I'm doing a binary logistics. In this case, I have the dependent variable, then against the age groups, where I'm able to set my reference, whether I'm using the first or the last, continue. I'll be able to even take how to get my classification plot, crude oil ratios, any other parameters I have. Then I run it. So this becomes what? So all of them, you are going to have what? This expected beta oil ratios. And this is what we call the crude oil ratios. Now, if you look at the multivariate, it's the same thing approach. But in this case, we are just analyzing more than what? One variable. So it's a multivariate, and each of the variables are adjusting to each other. So that one, instead of age group, let's say, in addition, I'm analyzing what? Gender in addition. And as soon as you analyze, you could see that everything is going to change. The all ratios that we had for age group in the univariate will be different from that of this one. So we adjust. So there's a way we do all these things, and because of time, that's why I did not really touch on them, which is good, yes. So always the univariate is give you the crude oil ratios. Crude means you've not adjusted for anything. But the adjusted one is you did a multivariate, more than one variable, and each variable is adjusting to each other, or each variable is a co-founder to the other variable in the model. Yes, yes. You can continue. Yes, good. Yeah.
Yes, thank you very much. But please, I don't know, multivariable and multivariate. I think that multivariate is where your independent variables, your dependent variables are more than one. But yes. I heard multivariable. So I don't know if it should be multivariable or multivariate. Thank you.
I think his concern was kind of adjusting the crude oil ratio. So as soon as we talk about crude oil ratios and adjusted, then we are talking about this approach. But if you move on to the
yes, so please, I was trying to draw our attention that I think it should be multivariable.
Exactly.
But he mentioned multivariate. Yes, please.
Exactly. So
thank you, sir.
Welcome. So exactly. So that one, if you talk about, so if you have a dependent variable of more than two groups, then we move to the multivariate. So that one is also another one. You go to the regression that you can move to. In SPSS, it's more of multinomial logistics, which will give you more variables. But regardless of any of them, as soon as you made measure of crude and adjusted, it means you are looking at the individual analysis and the multiple analysis, which you are good to go.
Hello, Mr. Neben.
Yes.
Please, the TA made mention of multivariable. I said multivariate. Is there any difference? Can he clarify, please?
So the difference is that, so for example, here, how many groups do we have here? We have two groups. Hope you get it.
Yes, please.
In this case, the group here, we can use the binary approach. But for example, if you are doing multiple groups at the same time, then we can go to a multivariate. Some of this things you understand when we do more practicals in advanced stage. But the bottom line is that when we are talking about a multivariate, we have multiple groups in even the dependent variables. There's a lot of groups other than two of the groups. Then we have multiples of also the independent variables against them. When we come to the logistics regression models too, for example, SPSS clearly shows you here. For example, in the case whereby we are dealing with this binary, but we do more multivariate analysis in our language, where we're able to manipulate a lot of them. A typical example of those handling multivariates is where we even doing genomics, doing the PCA, the T-SNP, all those kind of works, where we look at which principal components analysis are classifying into that. So those classical analysis, we do a lot of them there. Are we on the same level? We
Yes,
don't
please.
we don't want to also confuse with the beginners also. We want everyone to be on the pot. But if you want to know more, just let's interact, join more our trainings and review on it. Yes. Okay, yeah, Joshua. Really nice. We are interacting and discussing. Joshua, you can move ahead.
Right. Thank you very much for the opportunity. I would like to talk more about the variables.
Yes.
That's the multivariate and then the multiple,
Multivariate and
analysis.
multivariable. Yeah.
Yeah, multivariable. With a multivariable, it's normally concerned with you analyzing using multiple predictors.
Yes.
But the multivariate normally respond to multiple outcomes. That is basically the meaning of the but they are used interchangeably. Thank you very much.
Exactly. So the baseline is that mostly the dependent variable has more than two outcomes, and they will be played. So you can any of those outcomes are being predicted in the models. We do more in most such kind of training. Mostly there's even just training on multivariable or multivariate analysis. But don't convince that with models. There can be a multivariate analysis and it's in a crude form. It is not being adjusted for. So the difference, the first question, which is the difference between what? Crude and adjusted. They are all in different concepts. Then we are good to go. How we do adjustment and the rest all depends on one, literature, the data you have, and your story you have. If you come to read the medical field, variable like age and gender, they are constant co-founders. So in any adjustment model, whether they are significant or not, we add them to it. So we get to learn more in the future, which is really nice. And if we have more questions, I will stop sharing my screen because we are zooming, we've chipped into the break. We're supposed to have break to 8 to 8:30 so that 8:30 you can start the next session. I'll stop sharing my screen, and if we have any more questions, we can discuss. we have more questions. It'd be nice that, yes, we'll be more practical and interactive. Yeah. So now we do this more often, then we kind of learn together. Any more questions? Yes, Ralph. Ralph, I think, okay, so after Ralph's question, then we can go on a break. Yeah.
Okay, Shinaben, thank you so much. So on the inferential statistics, sometimes when you are analyzing the multivariate stuffs, sometimes you see when you are using one of the variables as a reference in some of the articles, you see asterisk. Is there any difference?
You see asterisk. It depends, because asterisk can mean anything in published paper. Sometimes we even use asterisk to kind of represent missing data. But so mostly if someone uses asterisk in any paper, they'll define it in the footnote. And as I said, maybe asterisk can also mean that the variable was not significant, but they still use it in the adjustment model. A typical example is age and gender, which are constant co-founders. So mostly if there's asterisk attached to any variable, check the meaning in the font notes. Then you further confirm the meaning of the asterisk. I don't know if we are on there, except they've used it in some context that we can discuss.
Yes, sometimes they will say reference. They will make it as a reference.
Okay. So for example, if you look at the paper that we just go through, you see that the reference we use, we only put 1.00 at the reference. We didn't indicate any asterisk there. So for example, if we are using gender in the model, gender has what? Male, female. So in any prediction model, one of them has to be a reference. So for example, you see that we use the male or the female as a reference and predict the order. So if they are using that as a reference, it means that the interpretation of the results will be that, let's say compared to male, females has increased odds of this. Then you are good to go. But other than that, mostly for models like logistic regression models, those that we use reference, like this paper we just went through, you see that all those that have 1.00 in the result column are the reference group, and we are good to go. But that's the meaning of the reference group. It means they are comparing all other variables or data in the group to that point. And that reference you set depends on your literature. So for example, let's say we all know that maybe well-educated people will have the possibility of, let's say, accepting the vaccine. So it means that if you are interested in, you want to say a story that these people that will have increased chances of not accepting a vaccine, it means in the model, you are going to use what, like those that are having tertiary education as a reference. Then you predict for those with junior high school education, basic education, or secondary education. Then you're able to talk more to your reference group. I don't know if you're on the same grounds.
Yes, please. Yes, please. Thank you.
Great. Okay, so I say thank you very much for the wonderful session we've had so far. And it's been a great interaction with you. And we hope to do more if you happen to join any of our sessions. It's not only in anything concerning research, data analysis, we are involved. Let's interact more and follow us on social media. Thank you.